Connor. Welcome. This is the second of our dissemination forums. For those of you who are new to the Open Networks project, I'll probably just give a quick recap what Open Networks is about. At its core, it's a collaboration of 9 electricity system operators across the UK and Southern Ireland. The aim of the Open Networks project is to support the move to net zero emissions by the transformation of our electricity networks into ones that are both flexible and smart. The Open Networks project's been going now for about 5 years, and throughout those years we've always sought to keep the wider industry informed of what we've been doing, our work, and we've always sought as well to get input from the wider industry to help massage the work that we do into something that is useful for the entire industry. This year we've introduced the dissemination forums, and this is the second one this year. And this is alongside our challenge group forum, and this is really to formalise the relationship between the wider industry and the project, and make sure, one, that we are disseminating to the wider industry all the work that we're doing, but two, to take feedback from yourselves so that we can actually make sure that we're hitting the right note in terms of the work that we do. So today, if we look at the agenda, which is on the screen in front of you, we're not going to go through all the work that we've been doing this year. We wanted to cherry pick ones that we felt were delivered. So we wanted to cherry pick those that we felt had delivered something that would be meaningful for you guys in the first half, that's been delivered in the first half of the year. So in a moment, I'll be handing over to my colleague Ben Godfrey, who will be taking you through the flexibility work stream and the particular projects that they've been working on this year. After a short break, you'll be coming back to me, and I'll be taking you through a couple of projects for the whole electricity system work stream, and then we'll give you another break, and that will be followed by Jim, who will take you through some of the customer information work we've been doing. And then I think we'll have a short presentation from Farina, who is head of the Open Networks, and she'll be giving you some updates on the wider programs. And finally, I think Emily Jones will be giving you some information on the latest upcoming ENA events in addition to this one. So without further ado, unless there's any questions at this point, and I'm not imagining there will be, I'll hand you straight over to Ben, who can take up the reins and give you the update from Workstream 1A.
Excellent, thanks Ian. As well introduced there, my name is Ben Godfrey. I look after Workstream 1A, which is the flexibility workstream within Open Networks. I work for Western Power Distribution. I'm the Distribution System Operator Manager. So Workstream 1A is very much about giving, building on the detail about all the elements that we need to deliver flexibility. The idea being that we want to create standardization and really deliver a convergence of flexibility offerings across distribution network operators and national system operators in the UK, making sure that we're removing barriers to accessibility, delivering commonality of offerings, and making the kind of customer journey for delivering flexibility on the network as simple and as smooth as possible. And this idea about delivering end-to-end processes that enable flexibility is very much at the core of what Workstream 1A is supporting. So over a number of years, as Ian said, we have improved and developed the workings around flexibility. And this year is just one of a number of those years where we're building up what is the next critical block and development that we as an industry, and from the consultations that we've had with wider participants across the industry, what do we think is most pressing and what needs to be taken forward. So within this year, we have quite a wide program that looks across the whole chain of flexibility and making sure that we're developing out and improving access to flexibility markets, so really developing those markets. And what we want to try and do today is just take you through a couple of those key snapshots, these elements highlighted in orange, which we think will give a good taste of the work that we're doing and show some of the progress and development that we've made. Looking at sort of recent areas, then one of the key data sets that we provide back out to the industry is the UK-wide flex figures. That shows the kind of procurement volumes and the amount of activity that's going on in distribution flexibility, and this is an area we're really proud of. We've grown the amount of flexibility from in the low double digits all the way up to a multi-gigawatt portfolio that we're now seeking on. And I think if you compare how the UK is developing compared to the rest of the world, primarily leveraged because of the great incentives and the forward-thinking regulation that we're working under, you can see that the UK has very well developed flexibility markets, and network operators have really embraced those and have taken them to the market. We like to try and engage with industry and other actors within the flexibility space. So every year we do a flexibility consultation, and that aims to draw out what the most important objectives are within flexibility and making sure that Open Networks is keeping pace with those. So we have many different products that we do over multiple years, and it's really about incremental improvement and pushing forward on the progress of flexibility. So we've got a couple of elements as well, P3 and P4, that are looking about simplifying the flex service provision. This is a very difficult challenge to take something that's quite complex and make it the customer journey, the flexibility service provider journey, as simple as possible. But we've identified a few elements which we think we can take forward, and those are being undertaken in those particular packages. And then we've also made quite significant improvements to transparency of our actions through the publication of a baselining tool underneath one of our products last year. And that enables us to really provide tooling and a consistent methodology for network operators and DSOs to be able to understand what the normal position of a particular asset is, and then understand the delta that is being delivered through flexibility, through that commercial service, so that we can fairly reward participants when they're able to provide a flexibility service. So as I said before, these three elements that we're looking at today, the overarching common framework for flexibility services, the common evaluation methodology, and the dispatch interoperability and settlement areas, those are three kind of deeper dives that we're going to be jumping into in just a few moments. So I think what I can do now is hand over to Avi, who's leading on the P0, and he'll be able to give you a bit more information about that particular activity.
Thanks, Ben. Can you go to the next slide, Head? Thank you. My name is Avi Aital. I am the technical lead for the Open Networks program, and also I am leading this specific product called the Overarching Common Framework for Flexibility Services. Next slide, please. Picking up where Ben left off. So this is how the workstream 1A structure looks at this year. So the way we've structured it is essentially, picking up elements of the flexibility lifecycle and address key barriers to market and the areas that are either needs looking or some sort of refinement, alignment, or any processes that needs to be picked up by networks. But through this entire process, what is perhaps not very apparent is some of these elements of work are incremental, which we go step by step. Some of them have been picked up in the past, brought to a certain level of maturity, and then reanalyzed after a few years potentially. So in while going through this journey, one thing became quite apparent to us, that although we are making a wonderful progress over the last 5 years, the overall big picture, perhaps where we've started, where we are now, and where we're heading, is perhaps not entirely clear in the way we work. So that's the reason early last year, Open Networks decided to have this overarching common framework for flexibility. And next slide, please. So this helps us contextualize where we start off in 2017 when the Open Networks program was launched. So that's when the DSO transition was in its infancy. So we had to come up with market principles, develop the market as it is from ground up. So ever since, we've been going ahead with great guns year on year with propelling this program forward, delivering the market where it is right now. So as of this year, we're at a crossroad where we've made a good development in BAU market for flex services, and there are substantial developments in the industry that are imminent. So this is a good opportunity for us to reflect and contextualize the journey we've had so far and where we're heading. So whilst we were reflecting on this, we also received a mandate from the Smart System Flexibility Plan. Next slide, please, Helen. So Smart System Flexibility Plan has identified open networks to deliver some of the key actions for the smart systems in the UK. So I've called out say 3.2 and 3.3 here, that because they are very specific to workstream 1A. So the points there are fundamentally delivering standard approach across distribution network and procurement service. So this is what you see remains to be the bulk of the work in workstream 1A, and we continue to develop those elements like define common services, approaches, valuing flexibility baselines, and all the elements that Ben just mentioned. And as we go down the list of actions, there was one other call out for us to come up with a common framework for flexibility that delivers an area of alignment and standardization across the flexibility services and ESO. So this then became not only an ask from an internal open networks perspective, it clearly became an ask from the industry, wherein we are able to communicate to the external stakeholders the good work we are doing here, and kind of perhaps contextualize where we're heading with this. So keeping that in mind, we set out to come up with two deliverables for this product. First one is the common framework for flexibility, which integrates the various component of flexibility works. And we are mindful that open networks could sometimes be very focused on words like products and work streams. So from an external stakeholder perspective, we were hoping to demystify this and keep it in such a way that if this is where to be flexibility as a concept, as a subject of discussion, how does it all fit in the grand scheme of things, and how do we capture that was the challenge we're trying to address for the first deliverable. Secondly, we then trying to translate that framework into what we call a strategic flexibility roadmap that sets out a clear view of where the areas of development are and what future perhaps holds. This then should give, I guess, the external stakeholders and network companies a good view of what we've committed and where things are going, so that whatever businesses or needs to be planned or some research needs to be performed is very clear to an average reader who is perhaps not too familiar with the year on year incremental development of Open Networks program. Next slide, please. So this is this is the what I'm going to be introducing today is essentially the framework, the structure of the framework. We are currently in process of populating this and trying to get the right information out there. But however, this is a good opportunity for everybody to take a look at how this is structured, so that that'll help digest the actual report or the actual framework that's going to be published later on this month or early next month. So this is how the flexibility framework looks like. It's structured in a fairly hierarchical way, so that so it's very clear that where the the mandate flows from. So assuming base directives sit on top, and we then have contextualized with Ofgem's baseline roles of network operation in their current baseline recommendations for the business plan submission. So the three roles identified by Ofgem are planning and network development, market development, and network operation. So we're using these as our kind of baskets of definitions, simply because if that is the language that going forward the government or BASE and Ofgem are going to be speaking, it's probably best if we can find a way to correlate our work to fit into those things so that there's a clear understanding and transparency in the way we work. So below the blue blocks, the three ones I mentioned are the ones which are blue outline white boxes, what we call T&D system operation functions. For some of you who have been in the past dissemination forum or who are familiar with open networks, every year we have something called a distribution system operation roadmap. There's a link on the slide below for if somebody is interested. So in there we capture the transition to DSO under different functions, activities, and steps. So we have different functions under there where each network company updates their individual status and tracks on the status. So what we have tried to do is try to correlate the off-gem baseline roles to the TSO functions so that, even though they are both elementally representing the same thing, there might be slight nuances or representation or words that might seem misrepresenting. So there's a correlation and that information is captured in a coherent fashion here. So below that, what is going to be captured as what we call key areas. So these are areas of development that are cutting across flexibility. It could be anything, any area like say forecasting, or it could be a market process development. It could be an operational dispatch or settlement issues. So there can be different areas or high levels of work that are going to be captured here. And they'll be categorized into three of those boxes. What you see in the triangle there, the green one, the dark green one, are the areas that are mature, and that's something that we've been able to deliver to a certain level of, or rather a business as usual level in the past 5 years. The one level below would be areas that we are currently working on. For instance, in one of the products, if you might have seen, would be the primacy rules, for instance. So the primacy rule is something that we are working on, and it's going to be something that's going to be core to the program for next couple of years at the very least. So those are going to be categorized as work in progress or initiated. And then there are some areas perhaps which are imminent and needs to be thought of, but have not been formally initiated in the landscape. So these are going to be captured in such a way that there is clear view of what are the activities or key areas that are mature, what are currently being worked on, and what the future holds for us. And the one which has the blue, dark blue highlight is the one action or certain areas of work that have specifically been identified or called out in the smart system flexibility plan. So this framework essentially would be like a one-stop view for anybody who has a interest in flexibility to understand where we are in the industry and where we are heading. So this then leads us very well to the next slide, wherein we set out a roadmap for this. So we are mindful that key areas, say for example, if you're talking about forecasting capacities within network companies, they will have, I guess, but potentially a sub activities that come under it, which needs to be worked on. So the intention is to capture each of the OPSIM roles in one strategic block like this. So for as an example, I've taken planning and network development as one role, which has say potentially 5 key working areas. Each work area would have say 3 or 4 separate activities, which are then going to be captured on a timeline here, which says what are the years which are in development, where it's BAU, and where the continuous improvement is ongoing. So this then gives a clear view of the entire landscape of flexibility, and also something that we can track on. So this is the current ambition for the program, and we are in the currently in the phase of populating these individual framework and roadmap with obviously content and not generic statements like key area 1 and 2. So that's something that we will be publishing soon, and probably be seeking inputs to the flexibility consultation as well. So I would say watch this space. But at this time, I think this is all I have for everybody here on call, but I'm open to questions now. Are there any questions? Feel free to raise your hand or come off. Hi, Mark.
Hi, Mark Somerville from the REA. Just obviously on that slide, you've done it out to 2027. Is that how far ahead you are looking, or are you looking further? What's the kind of time frame that you're setting out this strategic roadmap for?
That is correct. So the intention is right now to keep it more or less aligned to the ED2 timeframes, because what we are trying to do is come up with a collective view of all the networks as a whole, and not necessarily a trajectory for the program. So this is meant to be a representation of where we as an industry in the flexibility space are heading. So that's something that we have a fairly clear view of, because that's set out, in the Ofgem's expectation and in the business plans. So we can confidently say that this is what is going to be delivered. I think beyond that, there would be commentary on which areas will come, and the intention is to keep this roadmap up to date year on year. So as we go ahead and things emerge, I think we will then incrementally add those years on towards the end. But as of today, or as of the first publication, is likely to be limited to the time frame of ED2 end time.
Okay, understood. Thank you.
Welcome. Any other questions? If I think there's a question in the chat, let me just. This is thanks for the question. This roadmap, or the framework and the roadmap, is to be published ahead of the consultation and will be part of the consultation. So if you have access to the consultation document, you'll find link to this framework and the roadmap within that as well. The intention is to ensure that they go hand in hand, because some of the key elements that we discussed there, perhaps the more strategic questions would perhaps be answered by the framework there. So you'll find that potentially together by the end of July. Hi, John.
Hi. I was just wondering, what is the overlap, or is there an overlap or coordination between the idea of the coordinated, the standardized procurement by 2023, and the rules of primacy, and the work that NGESO is doing on things like single market platform and that kind of thing? Is that being coordinated through this project?
Specifically from the framework perspective, this is not meant to be limited to one or two network companies. This is meant to be capturing journey from DSO and ESO put together, and the primacy and the areas that we speak of would constitute an activity within these key areas that I've spoken of. So yes, there are individual undertakings from a network companies individually. We within the program liaise with all these programs and bring on the learnings or expertise as and when necessary, and we take this entire thing forward. But purely from a framework perspective, this is meant to represent the activities in flexibility space as a whole, not limiting to only distribution or transmission. That's why I said it's T&D, system operation functions. Does that answer your question, John?
Okay, thanks. Yeah.
If you have any further questions, feel free to drop an email onto the Open Networks mailbox, and I'll be happy to pick them up and respond to you offline if that's preferable. But I think the agenda, I think I still have 5 minutes, I think. So I'm happy to take questions. If not, I'll hand it back to Ian for the next slot. Okay, looks like no questions. Over to you, Ian. Thank you.
Yeah, good morning all. I've got Gary on the call as well. So Gary, do you want me to lead the slides and you chip in, or?
What you know a lot more about this, so why don't I do the slide bit and then you can add the value added part if you want, Ian.
That's the best offer I've had all day, Gary. Thank
you. I thought you'd accept that. Okay. Okay, so yeah, good morning everybody. My name's Gary Dolphin. I work within National Grid ESO, and I'm one of the product co-leads for workstream for product 1, which is the whole system CBA. But today I want to talk about not just that product, but another CBA that's been developed that I've been involved in. And so I'm going to try and keep it really high level, but just to give you a bit of feel and flavour of those two CBAs and why we've developed them. So if I can have the next slide, please. So yeah, a bit of background then. So in the last couple of years, the ENA Open Networks Programme has developed 2 cost benefit analysis tools in Workstream 1A Flexibility Services, we've developed a tool called the Common Evaluation Methodology and the associated CBA tool. And this tool allows a user, primarily it's going to be the DNOs, to evaluate flexible and non-flexible solution options and provide information and insights to the user for deciding on the appropriate solution. In the second tool, developed in Workstream 4, which is whole system, is called, not surprisingly, the whole system CBA. And this has been developed to allow the user to evaluate a range of options from a whole systems perspective. So they've been designed by different product teams, but they have been created in parallel. So the two teams have been talking to one another. So they've been working collaboratively and hopefully achieving consistency across the two pieces. So if I can have the next slide, please. So during the creation of the tools, as I said, both teams have been talking to one another, and there's been similar questions coming in to both teams for how to use the evaluation tools, how they overlap, you know, what those interactions are, and how potentially they're independent on one another. So what we decided to do is to try and provide a bit of clarity on this. We've written a report which clarifies the similarities, importantly the differences as well, and the interactions between those two evaluation tools. If I can have the next slide, please. So these two tools then in a nutshell. So the Common Evaluation Methodology tool and the whole system CBA. So the Common Evaluation Methodology tool, it's been designed to be used solely by distribution network operators to aid decision making about network intervention solutions by testing different flexibility strategies. The other tool, the whole system CBA tool, allows the user to consider different problems through a whole system lens. So if you remember just one thing from this presentation today, that's the kind of key high-level message to take away. Next slide, please. So let's just dive into that in a little bit more detail. So you can see we've got a little table here. We've got 2 rows in it, and the 2 rows are for the Common Evaluation Methodology tool and the whole system CBA. And then we've got a number of columns, and they just talk about various elements of the tool. And so that first column talks about the scope of the costs that are included within the CBA. And for the CEM in that first row, it only considers the DNO costs, whereas the whole system CBA, you can put in, if you want to, a whole range of different licensee and third-party costs. So it's a much broader coverage of the costs. The second element, the scope of benefits analysed, as I've touched on before, the CEM only looks at DNO benefits, whereas, not surprisingly, the whole system CBA, you can look at a range of licensing third-party benefits within the tool. Third column, the evaluation methodology. Well, they've both been built on the Ofgem CBA template. So hopefully, if you did look at the tools, you'll see there's a lot of things there that would be familiar with you if you're familiar with the CBA, the Ofgem CBA. But the CEM has various fixed parameters within it, whereas the whole system CBA, you have the ability within it to vary a whole range of parameters within it. The fourth column, the primary use case, well, for the CEM is very much designed to evaluate flexibility services, whereas with the whole system CBA, if you want to, you can evaluate a much broader whole system problem. In terms of outputs then, the CEM provides a financial analysis of each solution, and you can look at the optimal contract period, the ceiling price and the option value. Whereas in the whole system CBA, it provides a financial analysis of, not surprisingly, each solution, and you can have a sensitivity analysis, you can do a tipping point analysis, and you can look at distributional impacts as well. Next slide, please. So, this simple graphic is just showing that really, if you want to, you can use both kind of tools combined. So you can use the Common Evaluation Methodology tool shown by the dark blue rectangle. You can put your inputs into that tool, and then you can run it, and then you'll have the outputs, which will be, for flexibility services costs or energy efficiency costs or reinforcement costs. And you can use the outputs from the CEM tool as an input into the whole system CBA. So you can then run the whole system CBA, and once you've done that, you'll get your net present value of the whole system solution. So you can see then that whilst they're separate tools, you can use them in tandem to get a whole system picture. Next slide, please. So some conclusions then. Clearly then, both the CEM and the whole system CBA are both evaluation tools. We've built them both around the Ofgem cost benefit analysis tool. But the CEM is much more aligned to the Ofgem CBA. It only takes into account costs and benefits of the DNO user, whereas the whole system CBA has been developed to take into account a much broader range of costs and benefits from across multiple parties. So if you want to, you can look at both gas and electricity networks, or if you want to, you could consider, other energy vectors as well. You could put in hydrogen or etc. So you can really do, depending on what you want to cover in that, you can do a very broad scope if that's what you're interested in. The two tools can be used in conjunction, as I've said. So the output from the CEM can be used as an input to the whole system CBA. And of course, one of the obvious questions was asked was, well, maybe, you could combine both of these tools just so that you have a single tool. And we did look at that. We thought about that long and hard. But we've decided not to do that at the moment because they both have a kind of a distinct use. And also we felt if we tried to combine them, it might result in additional complexity, which might not be appreciated by users of the model. Going forward, yes, both tools are out there. You'll see them on our website, and we encourage people to have a look at them. There's lots of supporting material and documentation on how to use them and how they work. But we will continue to work collaboratively to ensure that, as and where possible, we will update the tools, the methodologies that underpin them. And we're considering two kind of different approaches going forward for the two tools. And in terms of the common evaluation methodology tool, we went out to consultation with it to look at how we could quantify uncertainty going forward, and we had some good feedback from a number of stakeholders on that front, and we're pursuing that at the moment, looking at how we might incorporate some of that within the model. Whereas with the whole system CBA, we feel that tool is pretty much it's pretty robust at the moment, and our way forward with that tool is to really just to kind of raise the profile of that tool. We're not going to do any further technical developments at the moment, but we're going to organise a couple of workshops in the first half of July, just to walk people through what we can do with the whole system CBA, and hopefully encourage people to use it and see the potential benefits of using that tool. I shall shut up at that point. I don't know if there's anything additional that you want to add, Ian, at this point, but we're more than happy to answer any kind of questions that you may have. And I see there's a question there from Anne-Claire. When would a whole system CBA be used by a DNO? Do they use it as a business as usual in their planning ED2 plans already? As somebody within the SO, I shall hand over to Ian to hopefully answer that question.
Yeah, of course. It was used to a very low level in the ED2 plans. Often after the ED2 or produced the ED2 CBA, they were sort of mandated for use. But Ofgem are encouraging networks to use this whole system CBA, and particularly in things like the CAM process, where you might move funds between networks to do the right thing for the greater good. Often are very keen, and in their guidance for the CAM process, they ask that the whole system CBA is used. So we spoke to all of the companies, the electricity companies, A number of used it in a number of niche cases, but yeah, it wasn't used broadly in the ED2 planning. But basically, any sort of use case that looks across sectors, that's what the tool's there for. So we're trying to push it out and get it used at the moment. We've got a list of people or parties or organisations who have expressed an interest in it. Most recently we did a project with Western Power and Region in Wales and West that used the tool, which was looking at, again, cross sector, cross vector, whole system solutions. So I think it probably in terms of the ED2 plan submissions, I think it was probably a bit of a step too far to be using the whole system CBA for that, and it does require information from a lot more parties. It's not just stuff you would have in house. So you'd have to, if you're an electricity network, you need information from the gas network to run a whole system CBA for investment plans in your area. So I think it was a step too far at this stage, but Ofgem are very bought into the tool. They're trying to promote it, and I think we'll see its use become a little bit more required by Ofgem as time goes on.
I see we've got a couple of other questions. One from Martin.
Yep, hi, thank you. So I'm Martin Caton from Low Carbon Electric. I'm just interested in the whole systems cost benefit analysis. Does it consider the speed to deploy and the resources required to deploy solutions? So I'm thinking in particular about congestion management, where there might be two solutions, one which can be deployed faster, therefore freeing up the workforce to do other things earlier, and something that might tie up the workforce for longer. But those two reinforcements might actually have the same cost attached to them. But there would be a benefit by installing the one that frees the workforce up sooner, and it being quicker to deploy over the other one. Does the whole systems cost benefit analysis consider speed to deploy and the resource required for it?
It's I mean, what it does consider in things like that is impact on a sort of public in terms of things like roadworks, etc. But as with any other CBA, it's only as good as the sort of data you put into it. So I would imagine if a job is taking twice as long because of the impact of delivering the roads, type of roads, etc., and all that would have an impact on cost to that. What a model won't do is tell you from a resourcing point of view, this is the right solution, because basically, as with most CBAs, you have to monetize everything. So, if it was going to take you longer to do a job because of the sort of streets you were working in, that would have to be monetized really, and the tool will give you an outcome. But it does consider, particularly, say, impact of roadworks, but much more in a social benefit sort of way rather than in a time to do a job sort of way.
Yeah, it's not really the specific installation I was thinking about. It's the fact that it might have the same cost, but it doesn't take as many man hours to deploy something. So it's not actually problems of doing things because of do you know what I mean? The cost is the same for the two solutions. It's just that one of them's quicker to deploy. Therefore, therefore the people that are required to do it is less.
Yeah, I mean, the tool's not a sort of person power planning tool in that sense. What we have tried to promote in the tool and the guidance is that consideration is given. So, say for example, we're looking at Bristol and what the future energy solution is Bristol with the local authority there. Looking at the requirements for insulation, etc. The tool does encourage you to think about the resource you need to do that sort of thing, and the practicalities then of getting that sort of resource in. So it does try and encourage you to consider resourcing, etc. But what the tool won't output is this is your better option because it's less manpower, or it's a quicker scheme to deliver. It won't output that sort of stuff.
could I just ask one further question? Is the tool
Yeah,
finished, or is it still under development?
It's we've done a first version of it, and we used Beringa to support us with this. So we did with the product team with representatives from across most of the networks. Beringa helped us with it because they did some good work on innovation, benefit assessment, and all that. So they were quite recognised and quite familiar with our sort of industry. That first version of the tool, and we spent the last 18 months trying to get it out there, get it used, collect as much feedback as we can, with a view to responding to that feedback and making any updates to the tool if deemed valid and necessary, etc. Pretty much without exception, all the feedback we get is the challenge is the data to get into the tool. So as an example, you might be looking at a new housing estate and business park, etc., and you're looking at multiple energy solutions for it to try and get the reinforcement data for the gas networks plus the reinforcement data from the electricity networks, the capital investment required and all that. We don't really have robust processes in place across the networks. So we certainly don't have standard of service and stuff like that to provide that sort of data. So all the sort of feedback we're getting is the tool itself, has a fair bit of flexibility. It allows you to consider a whole host of stakeholders outside of the network. It considers a wide range of benefits, etc. The tool itself is pretty good, but the data requirements to do a robust analysis are significant. So we're sort of reflecting on that as we go through this year. We're trying to get more feedback from others who are using it. So there may be a second version of the tool, but at the moment, all feedback is around, how do we make the data more accessible to feed the tool. So we're having those sorts of discussions under workstream 4 around, is there a new product then that sort of looks at the data requirements rather than a tool. So we're keeping an open mind. If we get any decent feedback suggest we should change something, update the model itself, we absolutely are open to that. But all the feedback to date has not been that. It's been all around the data requirements to put into it. That said, we've built as much into the tool as we possibly can to make the user experience as easy as we can. So I spoke earlier about the impact of roadworks. We've got costs in the tools associated with that. Cost of carbon, all these other lovely things you'd expect. As much as we can build into a CBA, we have. But things like what's the capex requirements on an electricity network to feed this new housing estate? Clearly, that's bespoke to that whole system CBA. So that's the sort of data that people are struggling to get. I can see some hands up still, but I'm struggling on my system to see who it is. Sorry.
Sorry, I may then. I'll just chip in. So Grant Wilson from the University of Birmingham, and look, really interesting, Gary and Ian. The question I had is, I think you pretty much just covered it, Ian. Actually, was around data and the issues about having, because you mentioned earlier on, even with the whole systems, about trying to get third-party data up from third parties effectively. I'm just wondering whether or not the tool, the experience, the challenge of this helps to sort of strengthen the case of even having a subset of data that is agreed by the sector that it's going to be within various ranges, or there's a kind of mid range for various types of things. Now, clearly, there's a lot of uncertainty with that, but at least it's somewhere to start. And the reason I kind of asked that is, the open modeling community would struggles with getting this type of data clearly as well. So anything that's bespoke data. So it's a great tool, but if it's for in-house and bespoke data effectively, I'm just wondering about whether or not other sort of data sets can be agreed as part of this sort of process with the sector itself, to basically say, look, if we're doing this type of work, broadly speaking, we would expect it to be between this value and this value.
so that it's in other sectors, building sectors, for example, there are rate tables and things like that, which are broadly agreed, and even having a spawn book effectively for the energy networks, if such a thing exists, that would be great, because it just opens things up and allows people to say, okay, well, we know it's going to be within a range, and if we get better data further down the line, then we can reduce some of the uncertainties with it. But at least it's a place to start. So I'm just wondering about that.
No, it's a fair. It's a good question. We don't currently have this sort of suite of unit cost style stuff. We've done something in gas as part of the hydrogen cost of conversion project, and NA project we did. But you've got a fair range between network companies of costs of stuff. I'm pretty sure electricity have something sort of similar within their networks, but probably not a common thing. So, I mean, it's good feedback. It's exactly the sort of stuff we're trying to consider now as a product team, because, like I say, all the feedback coming back is the data availability is the sticking point here. I think the challenge is, even if we publish a set of unit costs with a massive disclaimer on them, without how are you going to know the reinforcement or the how much cable you've got to lay to reinforce the electricity network, or how much pipeline you've got to lay to reinforce the gas network, etc. So it's not going to take away that interaction, I don't think, on a case-by-case basis with the networks. But it could certainly be improved massively, and if there is a good bit of feedback, which we'll add to our list, that if a set of tables that provide at least some data was helpful, we can have a think about that.
Well, look,
Sorry, go on.
Gary, sorry. I was just going to say, look, I mean, it's really helpful, even to get a sort of, better than an order of magnitude. It's a start, right? To basically, even to try and narrow things down. So that there's no way that it's going to be perfect. But just even somewhere, I think maybe part of it is it's an agreed number. So everybody knows the number's wrong. But because it's an agreed number, it's almost like a transparent set of things for people to then work off or work against. So and potentially over time, things can be tightened up around various uncertainties. It's just, I think it's really interesting to hear that in terms of the data and the process of just using this as a tool that then, the tool then makes it clear that the data is the challenge, and then for focusing on that and seeing what you can pull in from the sector effectively to help with that. Sorry, Gary, you wanted to say.
I was just going to say I totally agree, and I mean, for my day job really is doing a lot of CBAs around assets on the transmission networks, and of course when you start talking about costs, it can start getting very sensitive and people don't want to reveal them, and I spend a lot of time looking at interconnectors and trying to do CBAs around those, and of course individual CBAs, when we try and put anything in the public domain, we can't use specific project costs, not surprisingly, because the developers would go apoplectic with rage. But of course there's still some information out there in the public domain which does exactly what you say. You can put a ballpark figure around these kind of things, and it enables you at least to start the ball rolling in terms of being able to do some general kind of CBAs in terms of what kind of order of magnitude we're talking about. So I absolutely agree with your concept there. It's best to start with something, even if we all agree that there's going to be a lot of room for degrees of freedom in it, so to speak, but at least you can then start doing some analysis with it and get the debate going about how can we improve this data, because I think we've already realized very clearly that the input data is absolutely critical to getting any value out of the tool. Any more for any more? No. Okay. Well, final point. If you do have any further comments, then do drop a message into the ENA email, and we'd be more than happy to hear from you, and any further ideas you might have. We'll get back to you on those.
Thanks, Ian, Gary. Without further ado then, now because we're just about on track, if I can ask Joe Davey from WPD to pick up and talk about dispatch, interoperability and settlement.
Yep. So if I can have the first slide, please. Could we move the slide on, please?
Sorry, Joe, I think it might be stuck. Let me just quick. 1 second.
That's okay. Thank you. So product 3 this year, or workstream 1A, product 3, is building on the previous work that was carried out on these topics in 2019. The focus of the product is on the standardization of dispatch and settlement processes, and we've split that roughly sort of 50-50 throughout the year. So the first half of 2022, we've been focusing on dispatch, and we're just in the process of submitting the final recommendations from that. And we're about to move on in the second half of this year to focus on settlement. So obviously today I will be talking about the work we've done on dispatch. For the dispatch requirements, this product is considering interoperability across various systems. So that's including DNO, ESO, and some consideration as well of third-party platforms. If I could have the next slide, please. So to start off with some definitions, from the work in 2019, we had an agreed definition of what we mean by dispatch, which is the process through which the DNO informs a flexibility provider of the required level of service within operational timescales. And from that, we've then expanded that to come up with our definition of dispatch interoperability, which is one of the first deliverables we put out this year. And we've defined that as being a standard set of policies and procedures to communicate and instruct a service provider to deliver a contracted service. So what this is really about, achieving dispatch interoperability, will mean it's about minimizing the work required by a service provider who's successfully providing services to one system operator to provide comparable services to another system operator. There are going to be some overheads in doing that first setup, technical requirements and so on. So it's focusing on minimizing the effort involved once you've started delivering services with one provider to then provide it to other system operators. In terms of our approach to this, what we've tried to do is decouple the process of dispatching services from individual products as much as possible. And this enables us to minimize our dependencies on other workstream 1A products. And it also helps us reduce the risk of standardization, limiting future development of flexibility products. If I could have the next slide, please. So one of the things we've gone through and we found already is actually there is a degree of general alignment across system operators already in terms of the phases of dispatch, the processes that they go through for dispatching products. In some cases, these items sort of completing one of these items may sort of implicitly complete another phase at the same time, or it may be that a phase is effectively skipped over for a particular product depending on the design of the flexibility product. But generally, there is the alignment of these phases. So this starts with declaration of availability by the service provider. So those who are able to deliver services tell the system operator what services they can offer and when. The system operator will review these declarations of availability and will accept availability from certain service providers based on the network needs they have. Then following that, it may be done automatically depending upon the type of product. They will make a decision at a later stage to schedule the services that they want to operate from that pool of accepted offers from service providers. Then going down to the actual delivery of the service, and again, it depends upon design and operation of individual services as to if there would be an explicit instruction sent at the time they want the service to start running, or whether having scheduled the service, it would just be left down to the service provider to start the operation of their services at the agreed start time. But for some products, there will be an explicit instruction from the system operator to start delivery of the service. Again, then at the end of the time period where the service is required, there may be a cease instruction to stop the operation of services by the system operator, or for some services, again, it may be based on a pre-agreed schedule, and it's down to the service provider to stop the delivery of the service at the end of that agreed scheduled window. Then throughout the delivery of the service, there will be various monitoring of the services. After the event, you then have your post-action reporting, some of which will overlap heavily with settlement. So we've been relatively light in terms of our investigation of that at this stage. And finally, it may be necessary to cancel an agreed dispatch of a service, and that could be either because the service provider is no longer able to deliver that service, perhaps as a result of a fault in their plant, or it may be that there has been a significant change in network conditions that means the system operator does not want that service to operate anymore. So those are kind of the overall phases of dispatch, which, as I say, we found there is a reasonable degree of alignment on already. If I can move on to the next slide, please. So the current view of the work product group is that in the long run, we will be using APIs as the way to manage dispatch at scale and also in a more automated manner. But we have, in going through and comparing how we communicate dispatch at the minute, we've also concluded that it will be necessary to maintain other methods of communication of dispatch requirements, either as a backup option should API platforms fail, or potentially also as a method for engaging with smaller flexibility service providers who may not be willing or able to commit to the upfront costs involved in interfacing with an API platform. We've reviewed this, and the members of the product group are open to the idea of adopting a common API, but we need to be careful in the design of a common API such that it is suitably flexible to accommodate potential future requirements, and that we are not going to be limiting ourselves through the design of an API such that future innovations or new flexibility services cannot be fitted into that existing API. We've also, as part of this, been exploring sort of the key data and messages that would need to be exchanged to manage dispatch for a common API. And while the technical specifications are excluded from scope, the outputs from the group are basically a recommendation that we should be looking to develop a common API standard as further work in a future year. And it's also possible if it is possible, the preference will be to utilize an existing dispatch standard for this API rather than developing a new bespoke standard, if that can be done in a manner that accommodates all the requirements the UK network or UK system operators have for their dispatch API. If I can move on to the next slide, please. So I've mentioned APIs a number of times throughout this. I thought it'd probably be a good idea at this point to explain what do we mean by an API and what are the capabilities and opportunities an API could deliver. So first off, it stands for Application Programming Interface or interfaces. And effectively what this is it's a connection between computers or programs running even on the same computer. It provides a standard way of exchanging predefined messages between systems. So it allows you to transfer given set parameters or values between computers in a common message format that both systems can understand. Different platforms can utilize the same API, and it effectively hides the internal complexity of those systems, of those programs. All they need is to use this common API to be able to communicate between the two systems, and what the systems do in terms of their processing, how they carry out the processing of that data is irrelevant from the point of view of the other system. And this enables automated processing of data from multiple sources at scale. And so what I've got here as well, just to give you an idea of what these actually look like in practice, is an example of a National Grid ESO, Embedded Solar and Wind Forecast API. So this is their forecasting of solar and wind generation embedded within DNO networks across the UK. And so from the box at the top, if you make a query with your API to that given address and include the value of how many periods, your time periods you're looking at, it will return as part of its response this structured data format that shows you for each, I think it's half-hourly time period based on the number of them you've requested, what the embedded wind forecast and solar forecast are for each of those half-hour time periods. And it does that using a standard repeating data structure that then there are tools and packages out there that make it really easy to ingest and process that data within your own programs. If I could have the next slide, please. So thinking ahead about what could the impact of a common API be, if we can design a single common API that can be adopted by all system operators, what could that achieve? Well, first off, it's important to bear in mind that designing the API is just half the battle. Once we have actually got a standard, we'll need the input of software developers to implement this, both on the dispatch platforms, so that's the system operator side. They will need to do not insignificant amounts of work to build platforms that utilize that API, but then also it will have an impact on service providers' systems because they will need to integrate with the new API. There is a question which we're actually including as part of the flexibility consultation around where a system operator who already has an existing API, how long should they allow for service providers who are already using that existing API to move to a new API? What is a reasonable time frame to expect service providers to get that work done to move to a new API? The other key factor with this, as I've mentioned, is that it needs to be suitably flexible for future developments. So this may be the creation of new services, new styles of services in future. And one of the key things that will need to be figured out is how change management of this API works if it is to be a long-term success and actually something that system operators move to and stay with. But it does also create some opportunities. Adoption of a common API could lead to the development of more off-the-shelf solutions to interface with system operators' dispatch platforms. So potentially this will mean instead of each service provider having to bring in developers to develop something to interface with the API, there could be a standard piece of software or piece of hardware that they can purchase, and it would just be a case of installing that, configuring that, and then they can start providing services to potentially any UK system operator. So that is everything I wanted to present today. I open up to questions. Looking like we haven't got any questions, so I guess I can hand back early.
Yeah, and a final chance for any questions for Joe. Okay, well,
we got a hand raised from Andrew.
We have one hand up. Andrew Larkins.
Hi, thanks very much for a fascinating presentation, really interesting. In terms of the API, are you considering cybersecurity aspects regarding that, and also resilience, the sort of aspects which may be associated with power outage and restoration around these systems?
So technical specifications were intentionally excluded from the scope for this year's, and I say years, it's effectively 6 months work on this. These are details that definitely need to be considered once we get into the technical detailed design of the API. One of the key recommendations I've put forwards is that we need to ensure that we have suitable or that the design of the actual API needs to be done by software developers. At the minute, the representation has been electrical engineers, network engineers. They obviously need to steer the high-level spec, make sure what's being designed meets those purposes, is fit for purpose. But we are recommending that we get a software developer who should be familiar with and understand those requirements. So beyond specifying, it needs to be high reliability. Those are requirements we'll pass over to somebody who's got the expertise to ensure those are built in.
Okay, yeah, and within that also consider use cases such as cold start and restoration. So thanks very much.
Yes, okay.
Okay, are there any further questions for Joe? Can't see anything in the chat. No hands are raised. Thank you very much for that, Joe. I think we're more or less on track. We're just a couple of minutes short of 10 past, which is perfect. So the intention is now to take a short break, and then we'll be coming back to my section of today's briefing. So if we can all reassemble at 11:15, I'll pick things up at that point. Thank you very much. Welcome back, everybody. Alan, if we can move on the slide, please. To reintroduce myself, I'm Ian Povey. I'm the chair of the workstream 1B, which is the whole electricity system workstream. The workstream has a focus on enhancing and coordinating approaches between T&D in the areas of data exchange, investment planning, and operational planning. Its focus is on T&D, but we're also looking at how we disseminate to the wider community the data where possible, and let the wider community know what our investment plans are in the short and the longer term, and also increasingly in providing operational data to external parties. So the work, as I say, this work stream has been going a number of years now, and we've in the past put forward ideas about increased data exchange between T&D, and that has moved forward in the industry into code changes, both in the distribution code and the grid code. So there are changes going through those two codes as a direct result of the work of this work stream. As you can see on the slide in front of us, we have two areas that we're focusing on at the moment. We've got the investment planning area, where we're looking at future energy scenarios. That's how we forecast what the stresses will be on our networks. And I say networks because we're looking at that from a transmission and a distribution perspective, and making sure that we're all looking at this in a coordinated manner. We're using the same assumptions about what's going to be the challenges for the networks going forward. So my colleague Christos Kalounis will be presenting on that later this morning, on the ongoing work that we've done. It's a mature piece of work that Christos will be talking to you about, and it's really what we're building on year to refine and finesse that work. We're also, this year, all the network companies have published their network development plans, which is looking at what we foresee is going to happen on our networks in the 5 to 10 year period. So this really, the network development plan picks up from the long-term development statement, which is more in the present to 5 year period. So it gives you those two plans or statements give you a 0 to 10 years view of what network companies think they're going to happen on their network. And similarly, we've coordinated and put together a whole electricity system coordination register. This is a license requirement, much as the network development plan was. But what the Open Networks workstream has done is got the networks together so that we're presenting all the information in a consistent format, so that it's easily readable and understandable by external parties and stakeholders. Moving over to the left-hand side of that graphic, you can see we've got network operation and coordination. A large piece of work that started last year and has continued into this year is on visibility of distributed energy resource. This was a piece of work that had its origins in the famous loss and supplies in August 2019, and one of the problems that was identified with that extended outage was lack of visibility of DER on the distribution networks. So this was something we looked to address, and we've worked with the regulator to say this is what we think is a reasonable way to get the information that's currently not visible. There are other pieces of work going on like G99, which makes sure we're getting the data going forward, but this was a piece of work to say what should we go out there and collect that we don't currently collect. And my colleague Adelia Bertetti will talk you through that in some detail later on. We're also looking at and starting to publish more operational data from distributed energy resource. So this is a growing piece of work, but as I say, you can already find on distribution network operators websites operational data as of now, but that is set to increase. And looking at the data sharing, that's a piece of work that spans both the operational and the planning time horizons. And again, that is putting data out on our website so that you can see what is happening on our network as we speak. So without much more of ado, I'm going to hand you over to Adelia, and she's going to give you an update on the work of Product 6, which is looking at the visibility and monitoring of DER. Over to you, Adelia.
Thanks, Ian. Good morning, everyone. Can you hear me? I can
hear you loud and clear.
Good, perfect. Yeah, so good morning, everyone. I'm Adelia Bertetti, working the Smart Grid team in UK Power Networks. I'm leading Workstream 1B Product 6 activities on operational DR visibility and monitoring. So today I will give a 10-15 minutes overview on the work that we have delivered last year for Ofgem. Next slide, please. Yeah, so first a little bit of background on why the product was originated. So as Ian mentioned, on the 9th of August 2019, there was a power outage which was triggered by some transmission faults, which caused the interruption to over 1 million customers. So during this event, a large number of distributed generators tripped or deloaded, which caused a large frequency deviation, which triggered a cascade of network events, including low frequency demand disconnection to restore system frequency. So following this event, Ofgem has opened an investigation in the power outage, which resulted in 9 specific actions. And one of them was for Ofgem to investigate the option to improve real-time DG visibility, both for DNOs and ESO. So in August 2020, Ofgem has published a call for evidence on DG visibility, which highlighted the shortfall in the collection of distributed generator real-time data. And they highlighted their intention to establish a policy on DR monitoring requirements. So the industry responses agreed that there are significant shortfall in the collection of DG visibility. So they have then directed to ENA to work with DNO and had some specific asks from us. So if you can go to the next slide, please. Yeah, so we looked at a number of different activities, which I'm going to cover in the next slides. The key outcome was the assessment of the cost, which will be required to retrofit all the DR sites that DNO don't have any visibility over, and then also the benefits that this enhanced visibility will unlock, both for ESO, to DNOs, and to customers. So this was the key outcome of the product. If you can go to the next slide, please. Yeah, so we, in terms of scope, we restricted the boundary to be, so in terms of voltage level, we looked at from HV to EHV, so anything above 6.6, 11 kV to all the way to 132 kV. So distributed generator, not on DLV, so HV and EHV. In terms of DR type, we looked at just generation, we then look at demand. And in terms of connection date, we looked at, so applying that retrospectively, because as Ian mentioned, going forward, so all customers being connected after April 2019 will need to be monitored as part of G99. And so also I think it's important to clarify that this refers to DNO metering rather than customer metering. So we know that for billing purposes, very small units on DLV will have to be metered. But so these works refer to real-time monitoring from the DNO substation to the control system via SCADA. So that refers to operational metering. Yeah, so if you can go to the next slide, please. Next one. Yeah, so we first started defining some use cases that would benefit from enhanced visibility. So we have defined 14 of them, which we grouped in 4 main categories. So the first is DR providing service to the DNO only, which includes flex connection use case, flexibility service use case. Then DR providing service to the ESO, which includes auxiliary balancing services, system restoration, and so on. Then the next one was DR providing service both to DNO and to ESO. So this is the resolving conflict of service use case. So having enhanced visibility, how will that avoid conflict of service between DNO and ESO? Then the next category is improvement of existing processes. So this includes system resilience, improved real-time operation, improved outage planning, improved network planning processes, and so on. And the next one was the market facilitation, which is not a current use case, but is more like a future use case. So yeah, facilitation of new markets like peer-to-peer trading. How does enhanced visibility facilitate that, basically? Next slide, please. Yeah, so the next requirement from Ofgem was to define a data point list associated to distributed generators for the identified use cases. So beside operational metering, which includes active power, reactive power, voltage, and current at the point of connection, we have identified other data points which would be beneficial to be collected from the DR point of connection for the different use cases, which you can see, which are summarized in this slide, including more like availability data, like what is the portion of capacity which is in service, market data, which service has the DR been contracted to provide, forecast data from the customer. But then moving forward to deliver the CBA for Ofgem, we have restricted the scope to the operational metering data. So yeah, so we looked at megawatt, megavar, amps, and volts at the point of connection of the generator. Next slide, please. Yeah, next slide, I think. Thank you. Okay, so the next deliverable and the key piece of work that Ofgem asked for is a CBA. Yeah, basically carrying out a cost-benefit analysis on the of retrospectively retrofitting DR sites that DNO don't have any visibility over. If you can go to the next slide, please. So we first carried out a gap analysis on the total volume of generation sites, generation or sites that DNO don't have any real-time visibility over. And then based on the unit cost, like CapEx, OpEx, to retrofit the site, we have calculated the total cost, which is necessary to enhance DR visibility. And at the same time, we have quantified the benefits that ESO, DNO, and customer will see from this enhanced visibility. And basically, we have considered 4 different scenarios. So you can see in the orange box, the 0 kilowatts. So it's basically scenario 1 is retrofitting everything that is not monitored. So this also considering the boundary, which is HV and above. So retrofitting everything on the HV that DNO don't have any visibility over. Second scenario was retrofit anything above 200 kilowatt. Third scenario was retrofit anything above 500 kilowatt. And the last one was retrofit anything above 1 megawatt. And the result of the CBA were to inform the minimum DR capacity that is worth retrofitting. So we gave this information to Ofgem, and they are now taking like policy decisions. Next slide, please. Yeah, so you can see here like an aggregated view on the monitoring gap analysis. So basically each DNO assessed what is connected to their network from HV to EHV and assessed which of the sites they have real-time monitoring over. And then we have aggregated all these DNO figures together and got to the following results, which show that so there is a total of 35.8 gigawatt connected generators, which are composed by 7,050 sites. So DNO have real-time visibility of 28.4 gigawatt, so around 2,000 sites. So it means they lack visibility of around 20% of the, I think that was capacity, not site. Yeah, around 20%. and then we lack visibility of 7.4 gigawatt, which are around 5,000 sites. And then we went a level further. So we assessed among the sites that DNO have metering over. So we looked at which one is full metering and which one are partial metering. So full metering we define as P, Q, V, and I, so active power, voltage, and current, whereas partial metering could just be amps. So we went a level further and noticed that 24.8 gigawatt have full metering, whereas 2.8 have just partial metering. So we carried out a CBA based on this. We didn't look at the accuracy side of things, which is probably going to be in a next year type of scope. If you can go to the next slide, please. Yeah, so this slide breaks down the figures provided in the previous slide per voltage level and per DG capacity range. So basically, among the 7.4 gigawatt of unmonitored capacity, 1.5 gigawatt are connected to the EHV, and 5.9, so 78% of that, connected to the EHV, so 6.6 kV or 11 kV. And then if we look at the capacity breakdown in the second table, this shows that among the 7.4 gigawatt, 5.9 are in the 1 to 10 capacity bracket, whereas the capacity in the other capacity brackets is not much. So basically 80% of the 7.4 gigawatt is between 1 and 10, whereas the 0 to 200 kilowatt is just 3%, 2 to 500 is just 4%, and so on. Next slide, please. Next slide. Yeah, okay, so then we looked at the costs, and so basically we wanted to assess what is the cost of retrofitting these sites, and because it's highly dependent on what is already connected on site, we carried out some cost scenario. So for example, if there is already an RT, so also we couldn't go site by site, so we yeah, carried out some scenarios, and which then have led to the next slide. So if you can go to the next slide, please. Yeah, so this basically shows that the cost of retrofit site in the different scenario. So scenario 1 is retrofitting everything. The cost would be from almost 70 million to 131 million, depending on the scenario, the cost considered. Whereas if we were to retrofit just everything above 1 megawatt, the cost would be from 25 million to 41 million, so significantly reduced. We also looked at IT cost, so including storage cost to store the additional data points, the number of FAPs required to collect the data in the control system, and so on. And you can see the cost captured there. If you can go to the next slide, please. Yeah, so then we also looked at OPEX cost. So like for additional sites to be monitored also means there is the need for ops telecom engineer to go on site and like for fault resolution, battery replacement for RTU, communication costs, data storage. So these are the costs in the different scenarios. If you can go to the next slide, please. Next slide. Thank you. Yeah, then we look at benefits. And so ESO provided some benefits, DNO provided benefits, and then we combine everything together. From ESO perspective, the main benefits are to reduce thermal congestion cost, improve system resilience, and improve system restoration. So we have quantified, so each of the use cases that were previously defined, we have assessed the benefits. So these are the benefits from an ESO perspective. Whereas if you move to the next slide, please. From a DNO perspective, we have identified two main benefits, which would benefit from enhanced DR visibility, and this is especially on the HV, because it's 5.9 gigawatt are on the HV. So one is the flexibility service use case, and so enhanced visibility would allow to DNO to dispatch just what is required and not over dispatch, so like that is saving, and also real-time network operation, so avoiding the risk of APRS maloperation because of lack of visibility, basically. And we have quantified these two benefits. If you can go to the next slide, please. Yeah, next slide. Yeah, so this is the main slide. Is yeah, so we discussed that as part of operational metering gap analysis, it was identified that 7.4 gigawatt are unmonitored across GB, and this is mostly made up of 1 to 10 megawatt capacity bracket, which is so 80% of the 7.4 gigawatt is 1 to 10 megawatt. So basically retrofitting everything 1 megawatt and above will unlock a 6.6 gigawatt of capacity, whereas if we also decrease the bracket to below 1 megawatt, this would just unlock 0.86 gigawatt of capacity, so just 11% of the volume. Also looking at the benefits that scenario 4, which is retrofitting 1 megawatt and above, will bring compared to the decreasing the capacity size. We didn't see many benefits. So the recommendation we gave to Ofgem is that it is worth retrofitting generation capacity 1 megawatt and above, which is which will unlock 5.9 gigawatt among the 7.4 gigawatt of capacity which are currently unmonitored. And that's it from me. I'm aware I'm a bit out of time, so I'm happy to take any question. That was the last slide, sorry. Yes, this shows that the return on, so the time that it takes to the payback period to see benefits for enhanced visibility on the fourth scenario. So 1 megawatt and above ranges from 2 years to 12 years. Whereas if we were to retrofit everything 0 kilowatt and above, it would be also above 20 years. So we would not be able to see immediate benefits, basically. Good.
Thank you very much, Adelia. Have we got any questions for Adelia? Oh, hands shot straight up there. Lisa, would like to ask a question?
Hi, Lisa Waterswide. Did you do a comparison between getting the data in this way and putting all this DER into the BM and getting the data that way?
So BM would be directly from the customer, so not going through, so not being collected by DNO, RTU, and exposed to the control system. So it's directly from the customer or from the ESO.
But wouldn't it give you the same data? So because Bays was talking about making, for example, all the capacity market plant join the BM, if all those small plants then became BM parties, you would see pretty much the same type of data. I just wondered whether we should be looking locally rather than nationally.
Yeah, so we looked at also getting measurement directly from the customer, which is, so BM data gets measurement directly from the customer than from the DNO via other means of communication like API rather than SCADA. So this is not the process that currently DNO go through. So because it will require a significant upgrade in the control system to be able to get data through API to the control system, because the use case we looked at, so for example, real-time network operation will benefit from DR data, having this data into the control system. So we would need to find a way to get the customer data via API into the control system, and this is not currently something that is done, or at least it will require significant upgrade to be able to confidently make use of this data. So for example, if we lose communication with a site, there are some fail-safe mechanisms in place which are designed to keep the network safe, whereas we wouldn't have the same level of reliability with API data, and we wouldn't have all the redundancy in place.
Thank you. Can I ask a follow-up? Well, it's a slightly different question. One of the concerns that Bays and ESA seem to have is around knowing the availability of DER. Did you also look at finding some ways that the parties are actually telling the DNOs when they're available and when they're not available, even if they're not offering services?
Yeah, that's a really good point, actually. So as part of last year's scope, we this data point, but we're actually looking at this this year. So product 6 this year looks at other type of real-time data from the DR point of connection, whereas last year we mostly looked at PQ, and I, so operational metering, which was the key ask from Ofgem. But we are looking at it this year, which includes so whether or not a site is available, so because of their own maintenance, That means if it's not, you can't provide services, and also the volume which is in service, because it could be like a 50 megawatt plant, but just 30 megawatt are in service because like 20 megawatt are like under maintenance. So this is also a data point that we think would be really useful to get from the customer.
Thanks.
No worries.
Thanks for the question, Lisa. Is there any further questions for Adelia? Right, let's just see if there's anything in the chat. No, there's no questions there. So thank you very much, Adelia. That was a very complete and useful brief. So thank you very much.
Thank you. Thanks, everyone.
Thank you.
Thanks.
Right, without any more ado, I'm going to introduce my ENW colleague, Christos Kaloudas, who's going to take us through the standardization and alignment work between FES and DFESs that has been undertaken this year. Over to you, Christos.
Thanks, Ian. And well, it's technically still morning, so I can say good morning, everybody. My name is Christos Kaloudas. I'm forecasting lead with Electricity Northwest, and this presentation is on energy scenarios produced by DNOs and National Grid Electricity System Operator. And the topic will be more around the work we are doing to further standardize and align the energy scenarios. So if we can go to the first slide, please. Thank you. To better understand how much room we have for standardization and alignment, it's important to first remind ourselves or better understand that the different energy scenarios have different purposes. So when we talk about energy scenarios, we talk about the distribution future energy scenarios, the DFES that are produced by the 6 distribution network operators across Great Britain. And we're also talking about the future energy scenarios that are produced by National Grid's Electricity System Operator. When it comes to DFES, the primary purpose is the strategic planning of electricity distribution systems and networks. But there are also other purposes because we need to keep in mind that the local networks, the distribution networks, are the ones that supply the majority of demand. To this network we have distribution generation connected and batteries, so they go closer to local stakeholders, and the DFES also supports the decarbonization and other plans. They also support the local area energy plans. In Scotland, the local heat and energy efficiency strategies, and also the climate action plans. When it comes to future energy scenarios, their primary purpose is the strategic planning of the transmission network at national scale. It's also a second very important primary purpose that is around the national system operability and the security of supply analysis that is supported and uses as input the FES scenarios. There are also other purposes for the FES scenarios. They also support the wider energy industry stakeholder plans. And there is also mutual purpose for both DFES and FES, that they support each other. So for example, when we talk about DFES, these scenarios include the local trends and local plans that are reflected in them about distribution connected demand and generation that can be used in FES to understand the local and regional trends. And at the same time, in FES, we can find national data. There is the framework that is aligned with across all scenarios. And there is also information, importantly, around transmission connected generation that affects assumptions made by DNOs around the local generation and what the total mix means for the transition to net zero. So next slide, please. Talking about the alignment between the DFES, the distribution scenarios, and the FES, there is an initial alignment and feedback model that has been agreed between all DNOs and the ESO. This model was established just 2 years ago within ENA Open Networks, and at high level, this alignment process has been agreed and established to improve standardization, to better facilitate exchanges of data and information, to support whole system thinking and processes, and also to help the wider industry participants to identify network issues and opportunities. Next slide, please. Going now to a bit deeper to understand what this alignment means in practice. All DFES and the FES use a common scenario framework. So what this means, you can see the framework on the left-hand side. It's 4 scenarios that use the same, not only the same names, but also the same high-level rationale and also assumptions in the rationale of the assumptions across the various building blocks. So you can see 2 axes here that define this framework. The horizontal axis that is more around the speed of decarbonization. So the scenarios towards the right of these axes are the ones that meet net zero or have an accelerated decarbonization compared to the left. And also a vertical axis that is around the level of societal change. So the scenarios towards the top include higher levels of societal change to meet the net zero target. We have 4 scenarios here in this framework. At high level, it means that when we talk about same high level assumptions, it means that, for example, you might go to different DFES documents between different DNOs and the FES. And for the same scenario, you can find, let's say, high EV uptakes in both of them. Now, what high EV uptake means for different regions, it could be different because other regions move faster than others depending on local factors. So, for example, local socioeconomics. When it comes to things like, for example, heat pumps, it could be the building stock. It can be several other factors. But at high level, we should be expecting to see this same high level assumptions across all DFES and FES documents. Beyond the common scenario framework, the DFES and FES alignment is using a set of building blocks and a feedback loop in them that is, in practice, an exercise, a process of data exchanges. And these building blocks are apply for both demand and generation components. And what this feedback loop is doing is actually a comparison of forecasts that can facilitate convergence of assumptions where this is appropriate. So we can have a better look in the next slide on these building blocks. So this is the draft that is currently that has been agreed actually at this moment across all the DNOs and the ESO. Of the building blocks. It's a set of building blocks. You can see the full list. Well, it's an indicative list. It's pretty much these components here. It includes things like the dominant low carbon technologies for demand, like electric vehicles and heat pumps. It also includes information around the baseline demand, like domestic electricity consumption, the industrial commercial consumption, excluding the low carbon technologies. And it also includes some key technologies around renewables, like the onshore wind generation, photovoltaics, and also battery storage. Now, the building blocks, as I said, are used for comparison and alignment processes. The selection of building blocks are based on common and key technologies where direct numerical comparison is sensible. So, for example, you are not seeing any building block here on peak demand because this cannot be numerically aligned due to the different levels of diversification across voltage levels. And it's also that we need to highlight that DFES and FES consider several other technologies beyond these building blocks. These building blocks are more a vehicle to understand assumptions and converge where appropriate. But one should be expecting that in DFES and FES there are more forecasting components that are modeled and considered. So, for example, you can find in FES more information around nuclear generation. In DFES, you can find more information around various electric heating options for planned local stakeholder development plans. So, yeah, by all means, we shouldn't see these building blocks as, let's say, the full set of components modeled in DFES and FES. Next slide, please. Now, I've talked so far more around the alignment between the DFES and FES, so the scenarios produced by DNOs and National Grid DSO. We have 6 DNOs, so there is a process to standardize DFES across the various DNOs, And to do that, we've agreed to use a common methodology framework that is shown here. So in order to define scenarios, you can see that all DNOs are aiming to capture regional growth in its scenario. And this is done through using evidence-based stakeholder engagement inputs, considering customer information, using information around plant developments, around policies that might prevail at local level to national policies from local authorities. They take information around from local enterprise partnership and several other information from the local stakeholder engagement. In order to produce the forecast, there are 3 stages that we should see these stages as from a time perspective. So stage 1 is like our baseline, our let's say the as of now situation, and moving to stage 2 and 3, that is the longer term future. So in stage 1, every DNO is trying to understand more around the baseline demand and generation. And to do that, all DNOs are using measurements across the networks, and they also use information around the local data, around local characteristics, local customers, and they try to understand what is the baseline demand and generation in year 0, which is the base year. In stage 2, that is more around the shorter term forecast horizon, all DNOs are modeling what we call the pipeline. So in short term, there is more certainties around developments at local level. So DNOs are using information from connection codes. They use information from plant developments, and they use also information around network planning, because some planning decisions across DNOs could affect decisions of customers. So all these learnings need to feed into the DFES. In the longer term, all DFES are taking into account the zero carbon targets, what they mean at local levels, and any action plans from local authorities, like the local area energy plans, that give some more longer term certainty or framing of uncertainties around the trajectories to meet net zero. In terms of what the DFES outputs are, this common methodology framework defines that these are outputs around electricity demand, distributed generation, and storage. It's also seasonal outputs, and when it comes to demand, it's information around dailies. It goes down to information to time series profiles. Stakeholders can find more around DFES in the publications. So all DNOs are publishing the DFES reports, and there is regional forecasting data that can be found through different ways, through heat maps, through workbooks on the DFES websites of the DNOs. Next slide, please. Now, in terms of standardization of DFES, there is a 5th scenario that is used in DFES. So I talked previously around the 4 common scenarios between DFES and FES that align with this common scenario framework. But DNOs need to comply with a request from Ofgem, from our regulator, to produce a 5th scenario, and that 5th scenario is included in DFES, and its definition is as the highest certainty scenario that can be produced across all other DFES scenarios, focusing in specific uncertainties that can be justified in a 1 to 10 years horizon. Acknowledging that beyond that horizon, we cannot really talk about high certainties. There are significant uncertainties, for example, around the role of hydrogen in the longer term. So we cannot. Its best view is focusing more around the certainty. It's a scenario that goes up to 2050. That is the net zero target for UK, but it focuses on uncertainties in the 1 to 10 years horizon. Now, to produce the best view scenario, its building block, its forecasting component in the scenario needs to be checked against 3 categories, which is the way, let's say, the framework to comply with an approach to define the highest certainty. You can see on the right-hand side graph these three categories. So to justify certainty, starting from bottom left, the best use scenario needs to use justified stakeholder engagement inputs. So what does this mean in practice? It means that there is information that DNOs use to, there is evidence that DNOs need to gather about stakeholder engagement inputs. Such inputs can be connection codes. So DNOs need to understand more around the process for these connections, how many of them are going to connect, how many of them are going to, when they connect, how much demand they're going to meet, for example, compared to their contracted capacity. They need to understand, they can use different sources of evidence, so other DNOs might consider the historical performance of previous projects to justify these inputs for connections. Other DNOs might use more detailed information for some projects. When it comes to other inputs, it can be plan developments that don't have an associated connection code quote. So in those cases, DNOs can justify their use by providing evidence, for example, that in the best view will consider projects with secure funding, with strong support from local or central government, and all this information all this evidence needs to be provided to justify the use of these assumptions in best view. The second category is around the alignment with existing and national policies. So the best use scenario needs to align with national policies. In the full set of scenarios, for example, there are scenarios that might, for example, not meet. In the current framework, for example, there is one scenario that doesn't meet the target to meet net zero. The best view needs to align with national policies. In case that local policies prevail over national policies, the best view needs to provide that evidence that local policies prevail, and the best view needs to meet a local target, for example, or it applies for things like air quality zones that might prevail over national policies. So again, the best view needs to align with national policies, but there is some room here to consider local policies in cases that they prevail over national. And the third category is around the use of justified inputs for regional and local characteristics. So the best view needs to consider the importance of regional and local characteristics on defining the highest certainty in the short term. So for example, it needs to consider the things like the existing building stock and how this affects, for example, the adoption of heat pumps or the access to gas grid, and how this affects in the next 1 to 10 years the adoption of heat pumps in local level. So these three categories need to be applied to all building blocks, and through this process, the best use scenario is produced and can be seen again as the highest certainty scenario across all DFES scenarios. Next slide, please. So DFES, as I mentioned earlier, there is a DFES report that every DNO produces, and there is also data as part of this DFES process. It's part of a standardized DSO planning process. So when it comes to standardization, we should highlight that it's not only around how DFES is produced, but that it's one of, let's say, a set of planning processes that are standardized across DNOs. So the DFES the importance in DFES is that it captures this stakeholder engagement and uses information from local stakeholder plans and actions together with national policies and regional data. All that goes in DFES, and DFES is actually the inputs to two planning processes that are license conditions for DNOs. Is the network development plans that Ian mentioned earlier. It's license conditions since May this year, and it details future distribution network requirements for 1 to 10 years beyond publication. And it's also an input to the long-term development statement that is published every November with a May update, and this this document includes the future distribution network requirements for the next 5 years. So this is the end of my presentation. Happy to take any questions. And back to you, Ian.
Yeah, thank you, Christos, for a comprehensive presentation. Do we have any questions that anybody would like to put to Christos? Right, I'm not sure as we've got any in the chat. Let me just check. No, nothing there. Okay, in that case, well, it remains for me to thank you, Christos, for that presentation. If anybody does have any questions later on, I'm sure we can take them outside of this forum and direct them to Christos. But I think where we're up to now is to allow everyone to take a quick 5-minute break, and then we'll return. So if we can all be back by about 5-6 minutes past, we can then continue when we look at workstream 2. Thank you very much.
Come on, you're hungry, come on.
Just give people another minute to get their brew. Okay, welcome back everybody. The next session of this forum is looking at customer information provision and connections overview. The master of ceremonies for this part of the presentation will be Jim. So Jim Cardwell, I'll pass over to you.
Thanks, Ian. Great introduction. Hi there. I work for Northern Power Grid, but on Open Networks, I'm leading on this work stream. And if we can flip it on, please, Helen, just to sort of talk about what this work stream is all about. So it's about information provision to customers, aiding them to get hooked up, particularly with sort of decarbonisation connections and the contracting processes, and also communicating whole electricity system needs. And it sort of links through into those other work streams. And I think that the key point in terms of the work this year is that we're very much in a world of implementation at the moment, and also on sort of continual changing and continuous improvement to some of the products that we've put a lot of effort into the last couple of years. So the two that you see there on connections queue management in distribution, we are enacting that world and looking forward to sharing some information with you later on this year about how that is, some data with you to show you actually what's happening as a result of implementing those changes in the way that we've introduced a standardized way of managing connection queues. And we're also working with transmission colleagues to make those changes, to implement those changes in transmission as well. So that's going through a lot of the code review processes at the moment and change through that. And then on application interactivity, I think the main thing to note there is, again, that went live last year. And we are looking to continually change those processes and move them forward. And particularly, we're looking to review those in light of the significant code review into the access arrangements and seeing what implications that might have in the way that we need to manage application interactivity in the connections front end of our various businesses to keep in line with that changing regulatory policy. So that's what's going on in this sort of broader work stream, a lot of it in the codes. So that bottom tranche you see there on the diagram, that P0 overarching code reviews is really important because we've got a number of modifications going through code changes at the moment to enable some of that work that I've just described. But the area that we're calling out today is the one in orange. And as Ian said right at the start of the call, this is one of the areas that we've decided to highlight because I think it's of interest and there's a lot going on in that area. And we're going to be talking about what we're doing there to get more information out there about what distributed resources are connected to our systems and how we can move down a level and then how we can manage that complexity from the 1 megawatt limit we've got at the moment. So I'm joined, if you want to move it on, please, Helen, by two colleagues who are going to take us through that. They're both called Steve, which makes my job a lot easier. So I'll hand over to Steve at this point. Thank you.
Thanks, Jim. Thank you very much. Yes, I'm Steve Halsey from UK Power Networks, and I'm the product co-lead here. Steve, do you just want to introduce yourself as well?
Morning, I'm Steve Field from Scottish Power Energy Networks. I'm the co-lead on this product, focusing particularly on digitalisation.
Lovely, thank you. If you could move on then, please. So, here's the agenda, just a sort of fairly brief agenda of what we're going to cover today. So first of all, what the embedded capacity register is. If you're not familiar with that, and if we've got a screenshot, an example of what that looks like. Some of the background to getting to the position of having an embedded capacity register, where we are currently and what's coming up in terms of planned activities for the development of the embedded capacity register. I'll tell you a little bit about some of the challenges that we've had in moving to a lower threshold. And then ultimately, Steve will talk to you about digitalizing that, because we fully recognize that having a spreadsheet in a modern world is far from ideal, and certainly least of all for the DNOs who need to populate that, but certainly from a consumption point of view, there's far better ways of doing that. So that's really what we're going to cover today. If you could move on, please. So the embedded capacity register, as it says there, it's a list of generation projects that are already connected or are accepted to connect to each DNO network and or IDNO network with a capacity of greater than 1 megawatt. That is what the current embedded capacity register comprises. And it was developed under the work stream that Jim is the chair of, quite obviously. It's published on a monthly basis by all DNOs, IDNOs, in a common spreadsheet format that was developed over a period of time. And part of the scope for the work for this year was to lower the entry level threshold from the current 1 megawatt down to 50 kilowatts. That significantly increases the amount of data that DNOs would publish. Most DNOs are in the order of probably 600, 700, 800 entries at the moment for the 1 megawatt, and that's likely to go up to around 3,000 to 4,000 for most of the DNOs. So again, a significant increase in the level of data. And Ofgem were quite clear with DNOs that there should be no less granularity to the data that's provided when that threshold is lowered. So that's meant quite a challenge. And as I said, that spreadsheet, it isn't really fit for purpose in today's world. So we're going to look to move to a digitalized solution. Thank you. Okay, so that's a snapshot of an embedded capacity register. I say a snapshot there. There's probably about 12 or 13 columns there, I think, from memory. The full register is much wider than that. It contains I think 54 columns from memory. I should know the exact number. But just to sort of give you an indication and a walkthrough of those, really. So there's a reference number, as you can probably imagine, to that. And an MPAN, an export MPAN that is published, the customer name, the customer address, the county, postcode, geographic location in terms of that's it, thank you. Geographic location in terms of eastings and northings, the grid supply point that it's connected to, and then the downstream network, the point of voltage connection, and the type of technology for up to 3 current different types of technology that go further to the right there. So it's quite a comprehensive piece of work, a comprehensive list of all of those resources, as I said, that are currently above a 1 megawatt that are connected or accepted to connect to the network. And that's been the format now that we've used for probably I think it's 2 years, coming next month actually. And when we move to a 50 kilowatt entry threshold level, exactly the same columns, exactly the same spreadsheet in its current format, but probably split into 2 rather than having all of them in a single spreadsheet. What we're probably looking to do is to implement a second spreadsheet for that 50 kilowatts to the 1 megawatt level, just to make it a little bit more manageable from a completion and digestibility point of view. Okay, if you could move on, please. So that's what it is. How did we get there? Well, it started out life probably 4 or 5 years ago as a system-wide resource register, and that came into being again as a result of the Open Networks project, and that ran for a couple of years, and it looked fairly similar to what you see now in terms of the embedded capacity register. But a Jacusa change proposal was raised by the BEIS panel of technical experts, and that panel of technical experts are the ones responsible for informing grid or helping grid to understand what sort of capacity margins they need to run their network with to make sure that the lights stay on for all of us. So the first ECRs were published way back 2 years ago, as I've said, and the intention is, and customer feedback was, that lowering that threshold should be a desire, and that is pretty well where we are at now. And our plan was, and I'll tell you why it isn't that at the moment, was to go live in May last month with that 50 kilowatt enhancement. That hasn't happened, and if we move on to the next slide, I'll try to sort of cover off why that hasn't happened, unfortunately. So the DCP 350, which raised by the panel of technical experts, saw the introduction of the 1 megawatt limit. In order to lower that threshold to 50 kilowatts, we needed to raise a new JACUZA change proposal, a DCP 399 in this particular instance, and that was to ensure that all of the things that needed to happen to codify it, make sure that it was structured, done in a structured manner, were in place, and that included changing some of the legal texts that currently sits in, I think it's clause 31 within JACUZA, to formally allow DNOs to do that. So as the workstream lead, I was responsible for liaising with the organisation that manages this on our behalf, and that is Electrolink, and we did that very early on this year, and Electrolink shared with the JACUZA panel early in 2022, I think it was in February, that this would be coming, look out for it, and given that it was a relatively minor change, we were advised that by Electrolink that it should proceed straight to a change report, not requiring a working group, not requiring a significant amount of input from anybody, and that it would be a Part 2 matter, and a Part 2 matter means that it doesn't need Ofgem's approval, and certainly Ofgem have been party to many of the workstream meetings, so they knew it was coming, and as I said earlier, they were the ones that were advising us that it should look exactly the same. So it was formally submitted to the JACUZA panel in May as planned, but it wasn't approved, and the reason it wasn't approved there is as you can see there, that IDNOs, who are also party to the requirement to publish these embedded capacity registers, said that they didn't have sufficient clarity or visibility on the requirements, and or indeed the reasoning behind the 50 kilowatt timeline. And what actually turned out was that that turned out to be absolutely true, and that Electrolink had unfortunately not actually published the document in the way that they said they would do. So when it actually went to the panel, of which IDNOs are part of that panel, they weren't able to approve it. So what that has meant is we're now in recovery mode, and the likely implementation date is going to be towards the end of this year. We're hoping not quite as late as November, but what we have done as that working group that has been established, and we have tweaked the wording slightly in the change report that was submitted. We've provided a little bit more clarity around timelines, i.e. towards the end of the year, and given a little bit more of an understanding and reasoning as to why a 50 kilowatt threshold was chosen. In the IDNOs were party to that redrafting, that tweaking, and all of those people now are happy with that. So the change report, the document, the revised document, is due to be back out with all of the interested parties very soon, and each of those interested parties will have a couple of weeks to comment on that. Hopefully there won't be too many adverse comments. That will mean then that we can formally align that and get that into a revised place, such that we receive approval, and we can then proceed with the publication of that data down to 50 kilowatts. Given that May was the planned implementation date, certainly the DNOs are progressing well on populating some of the data, or much of the data. the extra time that we are now given, extra 5 or 6 months that we're potentially given, should allow us to ensure that pretty well the spreadsheets, when published, are 100% complete and 100% accurate, because I can assure you that gathering the data for down to a 50 kilowatt level and in many instances manually checking each of the entries, each of those 4,000 or 5,000 entries per DNO is quite a challenge. So that's where we're at. Should have been published by now, unfortunately not, but we're in recovery mode and looking towards the end of the year for the likely implementation date. So move on, please. So, Steve, I think over to you, please.
Sure. Yes. Thanks, Steve. So, as Steve's already described, we're talking about a considerable amount of data when you think about a number of network companies publishing 4,000 or 5,000 elements of data with 50 columns multiple times a year, and currently done via spreadsheet. We have an overall program of digitalizing and putting more data-driven solutions in across the network companies anyway. So this is one area where we think we can do things differently and possibly make the data more accessible and easier to use and more interoperable across the different network companies. So we've done some work to look at what that would entail. And things like using application programming interfaces to be able to expose the data and providing mapping representations and other ways of accessing the data are the kind of things which we think are going to be of use and of interest to users. So we're at the early stages of that, I would say. I'm new into this work stream as well, so I'm probably got a bit of catching up myself to do, but some assessment has already been undertaken, and we've looked at options around whether we should publish a centralized copy of the data, or whether we actually should keep the data ownership where it exists and kind of bring it together in a central way. So the decentralized approach is the one that's been selected, and we're now looking at what we would need to do in order to start moving towards implementation of that. And you can see there's a link on in the slide here to a more detailed publication that gives a bit more background and describes the pros and cons of the different options that have been evaluated and why we've ended up with the decentralized being the recommended approach. I think that's probably the end of the slides here. So, any questions?
Yeah, thanks, Steve Field, and thank you for Steve Halsey as well. Appreciate both your updates on this product. So I guess more generally, if there's any questions for anything that the Steves have shared with you there, or more generally Workstream 2, they'd be gratefully received in the chat. So we've got one in here. Any Steve can pick this up from Jim Allen. In how confident are you that the data you hold now, even before the new 50 kilowatt level, is to the right level of quality, integrity, and visibility to enable sound business decisions to be made on it? So I think I'll nominate Steve Halsey. We'll go for a veteran Steve here rather than a new Steve on the pitch, I think, for this one. Mr. Halsey, what do you want to say to Jim's question there, please?
Well, thank you very much for calling me a veteran on the team, Jim. Much appreciated. Jim, yeah, I mean, that's a great question, and it's certainly something that speaking from a UKPN perspective, in the first instance, was something that prior to publication, certainly two of our directors, Mark Adolphus and Barry Hatton, were keen that I presented to them the level of confidence in that data. I've got to say, it's probably very easy to say that it's the data that we're publishing here is good as the data that we've had in through the front door at the inquiry stage. What some of the challenges that DNOs face often is that the inquiry that comes in through the front door is for a let's say a 50 megawatt solar farm and quite often the address might be adjacent to the A10. throughout the life of that project, the address becomes slightly better rather than land adjacent to the A10. We might know it as something else by the time it actually comes to energization and connection stage. And throughout the development of that project, that 50 kilowatt, that 50 megawatts might well have fallen to 48 or 46. And sometimes the making sure that we absolutely report on the data that is the right data and reflects what is actually installed can be a challenge. So can I say that every single DNO in every single instance is 100% confident that the data that they are publishing? I would say it's probably unlikely, but we all went through a very, very detailed process to make sure that the data is accurate and is 100% reflective of what is actually connected to our network, and therefore can enable decisions to be made on it. Of course, as all of the DNOs are looking to put in place DSOs, then DSOs are absolutely going to be responsible for managing the network on a more granular basis. So absolutely, it's important that that data is correct, and at the macro level, certainly for NG, to make sure that they've got the right capacity margins at the right times, it's vitally important to do that. There is, of course, a mechanism, and every DNO that publishes it has a link on their website to allow customers, if they believe or they recognise that their project has got some incorrect data, then there's a link on each DNO website to bring it to the DNO's attention to allow those alterations to be made. I think that's probably all I can say there. Jim, hopefully that answers your question.
Thank you, Steve, for that. That's great. Lisa, you got your hand up. What's your question, please?
Oh, hi, Lisa Waters, and I have to admit to being a member of the PTE, so this was partly my fault. One of the things that we've noticed in using the registers, which are great and a serious step forward, and welcome everything that is being done to improve them, is that it's actually the bigger sites where the data's incorrect. And that tends to be where the plant sees themselves as BMUs with beggars busy talking to grid, and when there's change of ownership and things, that doesn't appear to be feeding through into the registers. Is there some communication between grid and the relevant DNOs whereby when they get notice of a change of ownership, they also flag to you? Because that would seem to be useful.
There should be. And I've got an echo now. Why have I got an echo? No, that's better. There should be, Lisa, and certainly Rob Nickerson. I know he's only one single person from National Grid. He sits on our product group, and we look to try and make sure that happens. If it happens purely within a DNO level, then there's a novation agreement, and that novation agreement should be again reflected in the published data. Sometimes there is a lag between that novation actually happening and the data and the notice that has happened to allow it to be published in a timely format. But again, all I can say is, if you are aware of sites that are currently publishing the wrong owner, then by all means come back to me, come back to Rob Nickerson, who I think you know, and we'll do our best to make sure it's accurate.
Thanks.
Okay.
Thanks for your question, Lisa. And Steve, your response. Any other questions? No, I think that's it. So thank you both, Steves. Thank you for the questions from the audience. Ian, handing back to you. Thank you.
Thanks for that, Jim. Right, we're now moving on from the specifics of workstream updates to give you a view on what's happening on the wider picture for open networks. So I'm going to hand you over to Farina Ferrier, who is the head of open networks within ENA, to talk to you about the wider programs. Over to you, Farina.
Thank you very much, Ian. Good afternoon, everyone. So as Ian said, I'll be sharing a wider update across the program and some of our recent activities and what's coming up next. So if we move on to the next slide. So as you know, for this year, we set out quite an ambitious work plan for ourselves earlier this year. So as part of that, we've had over 24 different products across, the 6 work streams that we have in Open Networks, some of which that, you heard from the different presenters today. So overall, we've scoped out 117 deliverables, and now that we are halfway through the year, we've just done a bit of a check to see where we're at with that. So we have made quite good progress, and across that, we've delivered 42 of those deliverables. And I think was one of the things that we've done to make it easier for people to have better visibility of what's coming out from the program is we've developed a new timeline where we've mapped out all of these deliverables as they come out. So we've shared a link here to that. It's quite interactive. You can click on it and it kind of helps you show the overall development cycle as well. So I think in terms of recent activities, so I think a key area of focus for us at the moment, it's really starting to think about next year. So Open Networks has basically like been around for the last 5 years, and we've done quite a lot of work, but really at this stage, we're taking a step back, looking at what we've done over those years and looking at some of the key industry developments as well, and really thinking about how Open Networks can add best value next year and onwards. I think it's particularly important as we're entering, the next phase of the price control for DNOs as well. So as part of this whole overall scoping process, you'll be hearing more from us on that, and there'll be lots of opportunities for the industry to feed into that process. So you heard from Ben earlier today on our work on flexibility. So there are quite a few areas of work that we've made really good progress on. I think one of them is developing primacy rules, basically like helping to coordinate DNO ESO services and addressing conflicts for that. So earlier this year, we've been working towards defining those draft primacy rules, and currently we're basically like setting out the process for taking the trials forward for it to help refine them further. So I think that's one of the key highlights that we wanted to mention as part of the presentation today. So in terms of what's coming up next, so I think you also heard earlier from Ben, we've got a big consultation coming out at the end of July. So this is basically going to be a consultation on all of our work on flexibility to date. It's really the opportunity for industry to look at, where we've got with our development process and provide that input so we can actually take that forward. And then I think lastly, just to recognize across those 24 products and 117 deliverables, whilst we've made good progress, there is still a lot to do. So the focus for the second half of the year for us, really, it's taking the recommendations that we've developed so far, getting stakeholder input into that, and really kind of translating that across into implementation. So yeah, I guess that's kind of going to be the focus for us for the second half of the year. So I think that's all I've got in terms of the overall update. So I'll see if there's any questions, any comments or thoughts from the group. Mark.
Yeah, thank you for that. Really good to see. Obviously, in other spheres, we're expecting the big REMA consultations coming out from government as well, looking across the whole energy market. A lot of this, of course, will have impacts for the ENA and what you're doing there. How is your work stream coming up, factoring that in? How are you going to engage with the REMA process? And indeed, does the consultation at the end of July build that into consideration as well?
I think that's a great question, Mark. So I think REMA, as you've said, it's definitely going to be really important. I think it's one of those key developments that we've mentioned here on the slides. But I think the next milestone for REMA is a consultation that's going to be coming out in the summer. As part of that, I believe they'll be setting out the case for change and options as well. That's very much going to be a key input into our scope development process. So I think without, I guess, having visibility of what the options are, what the recommendations are, it will be difficult for us to kind of take that on board. I think particularly for the flexibility consultation that's coming out in July, but it is something that will be feeding into the broader process and making sure that, I guess, we're setting the right scope and factoring in, I guess, the direction of travel that comes out from that. I think it also applies to other developments as well. I think recently we've seen, I guess, developments on FSO. We've seen the call for input from Ofgem on local energy governance and institutions. So I think those are all the key developments that we are going to be like, we very much want to be factoring in as we set the landscape for next year. Does that answer your question, Mark?
Yeah, no, that's helpful. Thank you.
There's a question in the chat which refers to work around battery storage and whether we're factoring that into our work streams in going forward. I think, is that something you can pick up, or?
I might perhaps ask Avi if he's got any further insights on this.
Thanks, Farina. At the present times, there is no exclusive dedicated work stream or product looking at that specific technology. However, we are working with the LCT working group, who are specifically keeping an eye out on the technologies that are emerging and the barriers that they are facing. So if you can keep an eye out on all the work that if you were to look at a PID, we have a list of all the working groups that we liaise constantly in order to feed into our work, and this figures prominently in there.
Thank you very much for that, Avi. I hope that answers your question, Paul. Is there any further questions for Farina before we move on? I'm taking signs that everyone's happy, Farina. Thank you very much for that. Finally, moving on to our last item on the agenda other than AOB, I'd like to introduce Emily Jones, who is the Head of Stakeholder Engagement within the ENA. Emily is going to take you through some of the latest and upcoming events for the Open Networks project. Over to you, Emily.
Thank you very much, Ian. So we've got lots of events on, as always, and would really encourage all of you to attend where relevant. So we have got a whole electricity system webinar coming up on Monday, so very, very soon. What we'll be looking at for this is exploring what distribution networks, distribution future energy scenarios, and best view scenario are, and how these are used in network development plans. We'll also be sharing an overview of networks coordination registers, which were published first this year. And we've also got a whole systems cost benefit analysis tool workshop. So we've got two running across the next few weeks. So one on the 5th and one on the 12th, depending on when best suits your availability. These will be interactive workshops, so really welcome people along to give their views and opinions and thoughts. We also have a Next for Net Zero webinar coming up on the same day as one of the workshops, but later on. So this is going to be looking at decarbonising home heating, and this is something that our broader comms team is leading on as part of our general Next to Net Zero series that we run throughout the year. We've got Darren Jones, MP, speaking at this, and a list of other interesting speakers for that too. Then we've got a speaking event that we are attending, the ESO Power Responsive Summer event. So our very own Avi will be speaking at that on the 13th of July in person, shockingly. So if anyone is already planning to attend that, then do feel free to let us know, because we'll be around in the afternoon. And then just an early heads up, we ran a Business Green hosted webinar last year on flexibility, and it was a really, really useful event for us and really, really engaging. So we are going to be running the same this time in August, and what we'll be doing is in connection to the flexibility consultation, talking about how stakeholders can get involved, and then also just having a broader panel session and Q&A with a number of different speakers. We're hoping to get BAYS or Ofgem involved in that one too. So one more for the diaries, as that hasn't gone live yet, but that will be going live in the next couple of weeks. And then just a reminder that we put all of our events, so whether it's webinars, in person or networking opportunities, on our stakeholder event overview. So you'll see that link at the bottom of the slide. So if you ever want to keep up to date on what we're doing, then click on that and you can take a look.
Thank you, Emily. I'm not sure, are there any questions for Emily? I think she's run through quite comprehensively what's coming up in the near future. Okay, thank you very much, Emily. Before we disappear, I'd like to ask, is there any other business from anybody out there? Any questions you think you would like to ask us, and we can see we can direct it in the right place before we go? Not seeing any hands raised. Let me just check the chat. Paul's was the last one. Okay. Well, on that basis then, and no further questions, I think I can provide you with a wee bit of time left in your day, a bit of extra time in your day you didn't know you were going to have. I'd like to say that I hope you found today's presentations useful and informative. And I would also like to thank you all for your engagement and your questions. So with that, I'd like to just say thank you very much and goodbye.
Thank you.
Thanks all. Bye.